Hi, and welcome to our Mako webinar. I'm going to give you a little overview about the things we're going to be talking about today. First, we're going to go into a little bit of our own history, in case you're wondering who Arbiter is. We're also going to be covering the features and benefits of the Mako, and we're going to be demonstrating the Mako on some live testing. We're going to go over some of the parts of our website that have a lot of great information for testers and other backflow industry professionals. And finally, we're going to cover questions and answers. So if you have a question or you think of a question during the presentation, you can just go to the questions section of Zoom there, type it in, and at the end of our presentation, we'll go over any questions you might have. We'll go ahead and get started. First, who's Arbiter? Well, we've actually been designing field rugged digital test equipment for 20 years. We started in 2001, and most of our products are found in HVAC, but there are also products of ours in plumbing and automotive fields. All these fields have in common is that they're subjected to very difficult environments. So oftentimes there's a lot of potential for contaminations, falls, and all kinds of other external environmental factors that can affect the test kits. So we've developed over 60 pieces of digital test equipment, just as this test kit you see behind me, and we've done that for the last 20 years, have many more accessories. We're credited on 19 patents and counting. And we've applied our years of experience in building field rugged test tools to the backflow industry. So this test kit that you see is actually a complete ground up development that's specifically made for the backflow assembly tester. One of the nice things about a ground up development is you can custom tailor this equipment to exactly the application. This makes it a very easy to use test kit. Every detail on it's designed specifically for backflow testing. We didn't just take an existing gauge and put a manifold on it or any existing product. This is a complete ground up development. In fact, even the sensor inside, we spent over a year developing this sensor so that it could have the accuracy, response time, and durability that you need for backflow assembly testing. And another thing that makes this test kit really easy to use is it comes in the configurations that you're already familiar with. So here's the 5-valve configuration, which is our most popular, but we also have a 3-valve configuration, and we have a 2-valve configuration for you Mavericks out there. So whichever configuration you know how to test with, you can pick this kit up and start using it. If you're familiar with the test procedures, you'd be following the same test procedures that you're using now. So it makes it very easy to use. In fact, to make it even easier to use, we labeled all the knobs. So you can see the high, bypass, low, high bleed, low bleed valves are all labeled. So it's really easy to pick this up and start using it. The buttons are also labeled with little icons. This is the power button, which also doubles as the backlight button. The capture button allows you to capture readings as you're testing. And the back button is labeled, so you can go back to your previous reading or clear the display. So this is another thing that makes this kit really easy to use, is this very large, easy to read display. You can read this from a pretty far distance. You can also read it from a really wide angle. It's one of the problems with analog test kits is when you get sideways with the dial, it's kind of hard to tell which number it's actually landing on. Well, there's no guesswork here because the digital display reads the same from every angle. And so there's no ambiguity as to what the number actually is. The backlight is also great for a lot of low light conditions. We have that a lot here in the Pacific Northwest, just on normal days. But it's also good for really sunny conditions. Sometimes when the sun's really strong, it kind of wipes out the visibility of things. But the backlight button makes it gives you a lot more contrast, makes it easier to read. The rate of change graph right here is also a pretty valuable indicator. This will show you if the reading is increasing or decreasing. But a secondary function of it is it runs right through the sensor. So it's right in line with the sensor. This is really handy if you're leveling the gauge with either a sight tube, sight hose, or with an assembly as part of one of your test procedures. You often have to level the gauge with something. This line gives you a really clear mark where you can level the gauge. Another feature that testers love of our gauge is this hook. So there's a hidden hook that swivels and rotates on the back. So you can stow it away nicely here. We added this feature because one of the things we observed is technicians often needed a place to hang the test kit while they were working. Here in the Pacific Northwest, we have a lot of backflow assemblies that are down in vaults. So there might be a foot of standing water at the bottom of a vault. You don't want to put your test kit down in that. So our testers around here were using ropes and different straps to be able to create something they can keep their test kit off the ground. We added this hook so they can hook it on the ladders, the pipes, or even the assemblies themselves if they can have a place to do so and keep the test kit off the ground. So that's a really popular, well-liked feature. Another thing that makes this test kit really easy to use, I covered a little bit, is this capture button. So the capture button will actually allows you to capture the readings as you're going through your test. That's really handy. We saw testers out there in the field and they'd be in the middle of a test and all of a sudden the owner of the assembly or the owner of the property comes out and says, ask them what they're doing, interrupts them in the middle of the test, or they might get a phone call for some new business and they want to take that phone call. Well, if they didn't write down their numbers, they might lose their place, they might forget their values. We saw people writing down numbers on notepads with pens. Notepads would inevitably get wet because everything in backflow testing gets wet. And then the numbers would run. So we saw these problems. We thought, well, at least, we can have a place for them to capture the readings as they're testing so that when they get done with the test, they can then transfer that recording somewhere else. So this makes it a lot easier on you as a tester as far as giving you the confidence to know where you are in the test procedure and what your numbers were as you went. And as I mentioned before, the back button gives you a simple way to delete the previous reading with one press or clear the entire display by holding it down. So aside from being able to trust your numbers, there's a lot of other things that make this test kit the most trustworthy on the market. I already talked a little bit about the sensor, but it is the most accurate and fastest reacting sensor on the market. This lets you know what's happening in the assembly right now, not what happened before. This high accuracy is also across the entire range of working temperatures and pressures, which are found on the back here in this metal plate. So this test kit's working pressure is up to 175 PSI, and the maximum working temperature is 140 degrees. So that accuracy of this test kit is maintained in that 0 to 15 PSID interval throughout that range of working pressures and temperatures. This was actually one of the requirements of USC Manual 10. And one of the high bars, performance bars that standard set forth, which we were able to pass. This test kit is also very rugged and reliable. I talked about the sensor and what it can do, but I'm going to show you the insides here of what's inside the test kit. As you can see, there's no plastic assembly, there's no plastic diaphragm, there's no plastic diaphragm housing. The entire manifold inside is metal. That's lead-free brass and copper. That's put together with compression fittings. The sensor is housed in a stainless steel container inside of this brass housing. So what's actually coming in contact with the water is all potable water safe. Again, that was part of the USC Manual 10 requirements. And it's also really rugged materials. So we heard from testers that the most common failure points were these plastic diaphragms and plastic diaphragm housings. We eliminated those with these higher quality materials and construction. And because it's assembled with compression fittings and other standard fittings, if at some future date you needed to service something, you could do so without affecting the entire manifold system. So it's made to be serviceable and repairable as time goes on. It's also made for water. You know, this entire case is actually sealed and gasketed. That includes every possible point of entry here. But it even extends to the battery compartment. So even the battery compartment here has a gasket which runs around it. Every screw back here has a O-ring gasket. So it's all to keep water out. We also have a coating on the electronics to help prevent any damage if water does get inside. And these 4 AA batteries that you see here, they'll actually give you months of all-day testing. We had a tester recently tell us that he's an all-day tester, loves his Mako, has a couple of them, and he says he loves changing the batteries once a year. So get a lot of battery life out of this test kit. And I said the Mako's made for water. That doesn't just mean the durability of it, it also means the ease of use. As you can see, it's really easy to hold this test kit in any orientation thanks to these rails right here on the side, left or right-handed, wet or dry. And you'll see that during the live demonstration. This soft rubber material here provides a good gripping point and a nice edge to hold on to. It's not something awkward that you're trying to hold up. It's made to be held in your hand. We also have rubber on the knobs. So all these knobs are coated in a soft rubber that makes them soft to hold, but also has a pattern that allows you to grab when it's wet. So it makes it a lot easier to use when you're in wet conditions, which is always in backflow assembly testing. I talked a little bit about the USC Manual 10 approval. There's a bit of confusion out there and misconceptions. The USC Manual 10 standard has been around for over 10 years now, but we are actually, when we passed it in December of 2019, we became the first test kit to be approved by USC Manual 10 standards. Previous test kits were accepted under Manual 9. Manual 9 did not have the full gamut of testing and specifications that Manual 10 does in Chapter 10 for test kits. So that all they were saying when they accepted those test kits is that they could perform the test procedures. In Manual 10, in addition to saying that they can perform the test procedures, there's a whole gamut of tests and specifications that test kits have to meet. Some of these we already talked about. I talked about the accuracy and response time across the entire range of pressures and temperatures. But one of the things they have in there is a pressure fatigue test. Well, they'll actually pressurize the unit up to its maximum working pressure and then bring it back down to atmospheric pressure. They have a whole section of their lab dedicated to test kits. They do that 1,000 times and then check the accuracy after that to make sure that they didn't cause some kind of accuracy deviation by pressurizing it and depressurizing it 1,000 times. Another requirement of the USC Manual 10, which we had to spend a lot of time to learn how to design around, is actually the fact that the materials that it calls out for, anything that touches water, has to be NSF 61 and FDA approved. I already showed you the insides, how that's all lead-free, brass and copper. But when it came to the hoses, we looked around the market. We actually didn't see anybody using food-safe hoses. It makes a lot of sense if you're going to connect a test kit to test the potable water system, that it also not introduce contaminants into the potable water system. So I understand why that requirement's there, and it's an important one. And one of the reasons that we custom designed our own hoses. So here's a set of 3 that you would get with your test kit purchase. But there's some additional features that came out of these hoses. Aside from being potable water safe, our hoses are actually more flexible. So everybody else on the market was using refrigerant hoses, which aren't necessarily potable water safe, and they're a much stiffer hose. You can see ours, much more flexible. In particular, they keep their flexibility even when it gets cold. So you're gonna, a lot of times you have backflow assemblies, which might be installed in sprinkler boxes, or they might have the test cocks facing the wall. There's a reason 90-degree fittings exist, and that's because sometimes these are really hard to get to. Well, with a more flexible hose, you're not going to need to get those 90-degree fittings out quite as often. It's going to speed up your testing and make it a little easier for you. Another thing we noticed is that some of the refrigerant hoses that people were using had a really small diameter fitting here and a really aggressive knurling pattern. So that really tears up your hands and makes it hard to attach the hose to a test cock, especially if your hands are wet and it's cold outside. That might it's going to be uncomfortable. So one of the things we did is we increased the diameter of the fitting, as you can see here. We also made this a little bit gentler knurling pattern. So you're going to be able to get just as much torque because of that larger diameter, but it's not going to tear up your fingers as much as some of those refrigerant hoses that are being used in the market. A common complaint of testers when we asked them about their hoses was their leaking filter housings. Well, we saw the ones on the market. There was a lot of plastic ones that were leaking. So what we did was we changed that to an all brass housing so these can keep their dimensions better. We also put a double O-ring seal in here. In fact, sometimes people don't even know there's a filter in here. That's what this part of the hose is for. There's a filter in here, 2 O-rings, and you can open that with two crescent wrenches, clean out that filter whenever you want, whenever you think you need to do so. And you're not going to have the leaks every time you go to test. So now I've kind of given you a brief overview. I'm going to turn it over to Randy, and he's going to show you some live testing right now in our lab.
Great, thanks Adolfo for that introduction to the Mako. And I have here a double check valve assembly. And to save time, I've already pre-flushed my test cocks, set up my bleed off valve arrangement on test cock number 2, and my sight hose on test cock number 3. We'll be following the USC 10 procedures, and we'll test it using the Mako MK5 5-valve test kit. So the first thing I'll need to do is to power the unit on. And since it is a little bit dark down here, I'm going to toggle that backlight so I can see it more clearly. I do have a previous test save results there, so I'll just hold the back button there, clear those out so as to reduce confusion. I'll make sure all the test kit valves are closed and then proceed with the test. So the first step is to take the hose from the high side of the Mako and connect it to the bleed off valve arrangement on test cock number 2. And you can see, you can do this one-handed, as it's so easy to use. And once I've connected that, I'll slowly open test cock number 2. You can see the rate of change graph show you that, hey, the pressure is increasing. To make sure that I don't have any air trapped in the gauge or in the hose, I'll open the high bleed valve and bleed water through the gauge and through the hose. When I'm satisfied with that, I'll slowly close the high bleed. And the next thing I need to do is to slowly open test cock number 3. Fill up the water that is in my sight hose. Now you can see it fountaining out, so I can make sure I get all the air that may be trapped in the hose out. I'll close test cock number 3. And it's real easy, again, to orient this with the water at test cock number 3 using the rate of change graph and the water at test cock number 3. So now that I've maintained that that's the highest part of the assembly, I'll close shutoff valve number 2. If you're in a jurisdiction that requires the line pressure reading to be on the test report, which that isn't the case in our state of Washington, but maybe in yours, at this point after closing shutoff valve 2, you would wait for the reading on the gauge to settle and then use your left thumb there and press the capture button and call that your supply pressure. And we can close shutoff valve number 1 and proceed with getting the pressure differential across check valve number 1. And how I'll do that is just slowly opening test cock number 3. And now once the reading on the gauge has stabilized and the water is flowing from my sight hose at no more than a drip, Press the capture button, 1.6 PSID. And as long as it's over 1, we're good. So I'll close testcock 3, close testcock 2, remove my testing equipment for the time being, and open shutoff valve number 1. And in order to get the differential across check valve number 2, I'll set up my sight hose on testcock number 4 and my bleed off valve arrangements with high side hose on testcock number 3. There we go. Okay, now that's connected. I'll verify that my sight tube is still in place and repressurize the kit by opening testcock number 3. Once again, to reduce the risk if there's any air trapped in the hose, I'll open the high bleed valve and let water flow through. And when I'm satisfied that is sufficiently flushed, I'll close the high bleed. And now I need to fill up my sight hose yet again. So I'll open up testcock 4, let the water flow out. Similarly, let it flow for a little bit to make sure there's no air bubbles trapped in the sight hose that might throw off the reading. And I'll close testcock number 4. And so I'm already at the proper elevation. So all I need to do now is to close shutoff valve number 1. And in order to get the differential across check valve 2 now, all I have to do is open testcock number 4. Wait for the water to stop flowing or become no more than a drip on my sight hose. The reading on the gauge to be stable. I'll press the capture button. And after that, I can close testcock number 4, testcock number 3, remove all of my test equipment, and reestablish the assembly in the state it was in when I got there. And so just to review the readings on this test, 81 for the supply pressure, 1.6 for check valve 1, and 1.7 for check valve 2. And that'll conclude the double check valve assembly test here. And so I'm going to turn it back to Adolfo while I prepare the RP assembly.
Thanks, Randy, for that live demonstration. While Randy changes over assemblies, I'd like to go over a few things on our website, which is arbiterbackflow.com. So you can see a screen share come up here. This is our homepage. So from our homepage, that big circular button right there, that's our newsletter sign up. We're going to be launching several new products this year. Make sure you sign up for our newsletter if you want to learn, be the first ones to learn about those. We also have a section here that the FAQ. If you have a question about the Mako, we've probably compiled it here. So every question we get, we take those common questions and put them here. Nice thing about being able to answer them with this section of our website is we include videos, test procedures, outside links, all kinds of other information besides just a verbal answer. And speaking of videos, the fourth part of our navigation there, the video section. In this presentation, we're going to show one test kit, that's the 5 valve, the MK5, on 2 assemblies. The video section in our YouTube channel have a lot more test kit configurations and tests. So like I said, we have a 3 valve and a 2 valve version, and there's a couple other types of assemblies that we're not going to show. Some of those additional configurations can be found in the video section or on our YouTube page. One question we often get from testers, where can I buy the Mako? Second tab right there, navigation, the buy button, you click on that, it'll take you to the page with a map. This map has a map of our distributors. It's zoomed into the US, you can zoom out, or if you're international and see more distributors that way, zoom in on your area and zoom out. Below that is also a list. So you can find distributor on that list there. Another question we get is about test procedures. Are there test procedures included with the Mako? Yes. We include 2 double-sided laminated test procedures for the 4 assembly types, tailored to the type of gauge that it's going with. But a lot of times testers are testing the same assemblies a lot, and they might run into one type that they're not used to. We also have them digitally here on our website. If you just go support and then the model number test procedures, it pulls them up right here. So you can see a 2, 3, or 5 valve test procedure. This is really nice because you pull it up on your smartphone, and this is loads as a web page just like this. You could also download the PDF if you want to print it or do something else with it. Another question we get asked is, where can I get the Mako calibrated? Similarly, if you go to support, find a Mako calibrator, it takes you to our calibration page. Then you would click on the region or map that applies to you. So you go, this time we clicked on the East Coast, and you can see a list of calibrators and a map as well. If your favorite calibrator isn't on this list and you know they calibrate test kits, please contact us and we can reach out to them. If they have the equipment to calibrate analog test kits properly, they should also be able to calibrate our test kit. Another thing testers ask us for is they talk about recertification and want to know, is there a trainer where I can use the Mako? If you go support, find a Mako trainer, this pulls up a map of training facilities which have the Mako in the classroom. So if you're up for recertification or you just want to practice and use the Mako, these are some facilities that you can contact and see if you can get in and use the Mako yourself. Finally, for those of you that really love diving into details and want to know everything about the Mako, you can go to support, Mako operator manuals, and the 3 operator manuals are here. Click on one, say the MK5 as it was done here, and it'll pull up diagrams, specifications, and a whole bunch of other information that isn't, everyday stuff, and all the way down to the most minute details. But if the information you're looking for isn't there for some reason, you can always contact us and we will give you the contact information at the end of this presentation. So I'm going to turn it back over to Randy now so you can do a second demonstration.
All right, cool. Thanks, Adolfo, for that great information. And we have here a reduced pressure principle backflow assembly. Just like with the double check valve assembly, I've already pre-flushed my test cocks to save time, and that way you don't have to watch me getting myself soaked. I'll go ahead and put the stow hook back in its proper place. Now that this Mako MK5 is done just hanging out, we'll put it to work. As before, go ahead and power on my unit. Once again, toggle the backlight. I have my safe values still in there from the DC test, so I'll go ahead and remove those by pressing and holding the back button. And again, just a good rule of thumb, make sure all the kit valves are closed before connecting the equipment. And so now let's go ahead and hook up our hoses. So the first one I'm going to connect very loosely is the bypass hose, test cock number 4. I'll hook that up fully later on when we get to that point in the test. Next up is the low side hose of the Mako, nice and blue. Again, you can see how easy that is, just one-handed to hook up. And last but not least, we have the high side hose of the Mako going to test cock number 2 on this assembly. And one thing I'd like to point out while I'm getting that nice and snug, the hose filter housing, we generally tend to recommend you connect that where that is closer to the source of water. The important thing, though, is that you're always consistently hooking up your hoses so that debris doesn't pass into the gauge. All right, now that that's all connected, let's go ahead with our test. So the first step I need to do is to get my screwdriver and open up test cock number 3. And to reduce the risk of any air being trapped in there and giving us false readings, I'll open the low bleed valve. And similarly, now we'll open test cock number 2 fully and open the high bleed. Make sure that all that air is out of our hoses, out of the gauge. And once we're satisfied that that is the case, I'll go ahead and close shutoff valve number 2, and then close the bleed, the high bleed rather. And once the gauge is stable, as it is, I'll slowly close the low bleed. And then watch my vent port, see if there's any discharge of water. I don't see any. I have my parent differential across check valve number 1 at 7.5. If you want to capture that, you definitely can. Since it's not typically included on most test reports, I will delete that and just remember 7.5. Now, it's time to perform the relief valve opening point. And one way this is very easy with the Mako gauge is to hold the gauge like I am in my left hand with my left thumb poised and ready to go over the capture button. I can maintain my eye contact squarely on the vent valve. I don't have to try and look at the vent valve as well as the gauge. All I have to do is look for that first drop of water. So let's go ahead and open up the high control, 1 full turn. That's very easy to do. Looking at the text, just 1 full revolution, you know you're 1 full turn. And now with the low control, I just want to open that a slight bit, definitely no more than 1/4, and just watch. There's the water going. And then close the low control. Now that that's done, I can proceed to checking the tightness of check valve 2. The first thing I need to do is to bleed the air out of my bypass hose. So I'll open the bypass control knob and flow water through that hose, make sure all the air is gone, and close my bypass control. Fully tighten the hose on test cock number 4, and then fully open test cock number 4. So there's that, perfect. Reading on the gauge will adjust slightly. And now I need to reestablish my zone by opening the low bleed. Once that reading is in excess of the 7.4, 7.5, that was our apparent differential. I'll close the low bleed. And now it's ready to apply back pressure by opening the bypass. 1 full turn. Yet again, you just watch the text. You know where 1 full turn is. The reading on the gauge is stable. I don't see any discharge from the vent valve, so I can say, hey, check valve 2, you're holding tight. All right, let's proceed with the actual differential across check valve number 1. We'll establish our zone once again. Now that we're over 7.4, we can close the low bleed. And once that reading is stable, hit the capture button with my left thumb there. And I have the check valve number 1 reading. Now, if you're in a jurisdiction requiring the supply pressure, it's at this point that you would capture that. So what you need to do is to close test cock number 3, close test cock number 4, and simply open the low bleed. And once you're satisfied with the reading on the gauge being your supply pressure, just hit the capture button with your thumb, and then there you have it. So you have your relief valve opening point, your check valve number 1 differential, and your supply pressure. And we remember that check valve 2 held tight. So I'm going to turn it back over to Adolfo for the Q&A.
Thanks, Randy, for that great demonstration. At this time, I'd like to show you some contact information. If you do think of more questions, or if you want to follow up any other questions or comments to us, I'm going to share our website information here. The website is arbiterbackflow.com. You can email us at support@arbiterbackflow.com, or give us a call. We're on the West Coast, so generally keep Pacific time hours at 503-847-4936. I'd like to just thank you for taking time out of your day to learn about the Mako and learn about us and attend our webinar. And I hope you have a good rest of your day. Thank you. Goodbye.